it's Gina. I'm the nerdy math girl and I want to help you with your geometry. So right now, if you're in the polygons unit, that is what I want to talk about. So a polygon is a figure and it closes up and it doesn't have curved sides and it doesn't kind of go over top of itself. So if you have something that looks like this, not a polygon because it kind of goes over top of itself. But if you had something like 1, 2, 3, 4, 5, 6, I don't know, that's really ugly looking. But it closes up and there's no rounded sides and it doesn't go on top of itself, that's a polygon. This is actually a concave polygon. Do you see how this angle on the inside right here is greater than 180? That's what makes it concave. If you had something that was convex, okay, like you could have 1, 2, 3, 4, 5. That's a pentagon. It's not a perfect pentagon, but it is a pentagon. It has 5 sides, and do you see how none of these angles is greater than 180? So that would be convex. Concave, caves in, convex is like this, okay? Now, if we talk about a regular polygons have all the sides the same length and have all the angles the same measure. Okay, so it's like perfect. It's not regular, it's super special. It's super special because it can do all that stuff. So that's what a regular polygon is gonna be. So let's move on and talk about this. There's really only 2 kinds of formulas that you need for this whole thing. And really, it's just one of these 2. And this one's very specific. The sum of the interior angles is always the number of sides minus 2 times 180. Okay, so if you had a 5-sided figure like this pentagon up here, if you wanted to add up all of those angles inside, all of them, then you would say there's 5 sides, 5 minus 2 times 180. So 3 times 180 is 540 degrees. That's it. So if you had a regular polygon, then each angle would be 540 divided by the 5 angles. Okay, I'm going to show you more about that in just a second. Or if you knew that these angles were 100, 100, 100, 100, then you have 140 degrees left, and that would go right here. Okay, so you'd have to know that how much it adds up to. If you had a 6-sided figure, a hexagon, then you do 6 minus 2 times 180, and I think you get 720 degrees there. Okay, so this particular formula is good if you have the sum of the interior angles. Otherwise, I want you to use this formula, which doesn't look like a formula at all. Okay, so this right here is like up close, that. See how it's straight and then over? And this is the interior angle, and this is the exterior angle. Okay, that's what this is. It's up close right there. So we're gonna start with 360 over. The exterior angle goes here, or the n goes over here, whichever one you have. N is the number of sides. The interior angle for one interior angle goes right here. Okay, and these interior and exterior together, they're supplementary, so they add up to 180. So here's what you do every single time. The exterior angles always add up to a total of 360. So let's say that you're given that it's a pentagon, okay, 5 sides, and you're trying to figure out one interior angle. Okay, if you have to do the sum of the interior angles, then do n minus 2 times 180. But if you have to find one, then here's what I do. So you do 360 divided by either the exterior angle or n, so I know the n is 5. So if I divide by 5, then you get 72 degrees right there. That's one exterior angle. Therefore, since these add up to 180, one interior angle is 108. That's all. Easy, easy. Okay, let's say that you were told, you start with 360 over, and let's say that you were told that one interior angle was 120 degrees, and you're trying to figure out how many sides there are. So interior angles go right here, that's 120. These 2 add up to 180, right? So 120 plus 60 would give you 180. And then I'm just going to do the 360 divided by 60. I just do 360 divided by whichever one I have, an exterior angle or the n. So 360 divided by 60 means that n is 6. You have a 6-sided figure. It's a hexagon. It's not bad, right? Say you had something right here, and you were told that one exterior angle is 45 degrees. Okay, so that goes right here. This is the side for the exterior, this is the interior. So if the question says, so what's an interior angle? Easy, you just add up right there, and that's gonna be 135, because these 2 add up to 180. Or 360, and you divide by 45, right? And you're gonna get 8. So that's an 8-sided figure, an octagon. This one you use all the time. This one you use only if you have to have the sum of the interior angles. But if you can do this, I'm telling you what, all of those problems, you just have to look at it and say, does it ask for one interior or one exterior or the number of sides? And if it does, this is your go-to move. Yeah? Okay, so when we talk about polygons, one of the first things that you're going to talk about are parallelograms. And a parallelogram, every time you find out that something's a parallelogram, there are 5 things that are important. 5. You should memorize them, and they're easy. 2 are about sides, 2 are about angles, and then the last one's about diagonals. Okay, so you're just gonna memorize that. So about sides, the opposite sides, these 2 and these 2, right, are parallel. Opposite sides are parallel, both sets. Also, opposite sides are congruent. These 2 are congruent and these 2 are congruent. Okay, so those are the 2 things about sides. Opposite sides are congruent and opposite sides are parallel. Then there's 2 things that are about the angles. So the opposite angles are congruent. So let's look at this. Here's a parallelogram. These 2 are opposite angles. So these are equal to each other. Easy. These 2 right here are equal to each other. Those are opposite angles. So far, opposite sides are parallel and parallel. Opposite sides are congruent and congruent. Opposite angles are congruent, these 2 and these 2. So the 2 are about sides, 2 are about angles. The other one about angles is that consecutive angles are supplementary. Okay, so these 2 add up to 180. Or these 2 add up to 180. Or these 2, or these 2, whatever. So if you knew that this was 60, then automatically, if this is a parallelogram, this is going to be 120, because these 2 are supplementary. If that's 60, this is going to be 60, because they are opposite angles and they're congruent. If that's 120, this is 120. Okay, so opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And there's one more down there. I don't know if you can see it. There it is, the last one. The diagonals bisect each other. So right here, if I have this parallelogram and I drew the diagonals, clearly this diagonal is longer than that diagonal, right? Obviously, that's longer. But the diagonals bisect each other, which means that this is cut in half, so each of those sides are the same. And then this is cut in half, so each of those sides are the same. So in order to be a parallelogram, all of this stuff has to be true, okay? It's all true, but if you can get any one of them true, then all of them are true, okay? It has to be both pair of opposite sides are parallel, or both pair of opposite sides are congruent, or both pair of opposite angles are congruent, or all the consecutive angles are supplementary, or the diagonals bisect each other, meaning both of them are bisected. This one's bisected and that one's bisected. There's only one more way that you can prove that parallelograms are congruent if you're looking at them, and if that is if you have one pair of sides, that means pair of sides, are both parallel and congruent. That's sort of an extra thing. Okay, so these 5 things definitely know. This one is kind of an extra one. If you have one pair of sides, like just these 2 sides, if they're parallel and they're congruent, then you have a parallelogram. Or just these sides, they're parallel and congruent. Now look, if you have these are parallel and these are congruent, nuh-uh. One pair of sides has to be both. All right, so if you know this, then you can do all kinds of stuff. So if you were given that this is 2x and this is 5x minus 1 or something like that, you could say if that's a parallelogram, those 2 are congruent, right? If you were given that this is 2x and this is 5x minus 1, then you could say those are opposite angles, so those 2 have to be congruent. You set them equal to each other. If this was 2x and this was 5x minus 1, right? Then these 2 have to be supplementary. Add those up, set them equal to 180. If you were given this, and if you were told that it's a parallelogram, and if this was 2x and this is 5x minus 1, since the diagonals cut each other in half, you could set that equal to that. Really, at this point, it's just a bunch of algebra. Geometry should not be bad. So the next video that I'm going to do is going to talk about the special kinds of parallelograms. You are not going to want to miss it. The one is going to include rectangles and rhombuses and squares, and I have the greatest poem. You are so going to want to be there. All right, I'm Gina, the Nerdy Math Girl. Hope it helped.